we've been looking at expected value in some gaming scenarios. Now let's take a look at some insurance cases. So the first one is going to talk about extended warranties. So Jackie is buying a new MP3 player from Best Buyers. The store offers her a 2-year extended warranty for $19. Now Jackie read in a consumer magazine that for this model of MP3, 5% of them will require repairs within the first 2 years at an average repair cost of $50. So should she buy the extended warranty? Okay, so the idea here is that if this item needs the repair, as opposed to paying $50, she only paid $19. Okay, so is it going to be in her interest to actually get this? So the probability that this item will need repair is going to be 5%. Now at this point in time, if we take a look at her net gain or loss, she will have paid out $19, but she will have saved paying the full repair cost of $50. So at the end of the day, she will be $31 ahead. Okay, so because she still had to pay out this money, so basically her repair cost her $19 as opposed to $50. So she basically made $31 on that deal. Now, if you do not need a repair, that will happen 95% of the time. All right, and if you don't need a repair, you're just out your warranty, so that'll be just considered -19. Right, so she paid out that money, but she didn't really need to. So let's find the expected value for this. Okay, so in the first case, the probability of repair was 5% or 0.05. Notice I converted that percent to its decimal in order to use that in this equation. And then the profit or loss to her would be positive 31. The other scenario is not repair. That will happen 95% of the time, and then that'll be a loss of $19. So if we go through that in our calculator and compute that, you would end up getting -16.5. So should she buy the extended warranty? No, she should not buy the extended warranty. So in the long run, the consumer can expect to lose $16.50 on each warranty purchased. If you look at it from the flip side, this company makes $16.50 on each warranty purchased. So the idea is, okay, yeah, to them, on some of the models of MVP players, they're going to come back for repair, and then the company has to foot the $31 difference. But on 95% of them, they'll just get $19 from the consumer and they won't have to pay out anything. So again, on one particular trial, either this thing will need repair or it will not need repair, right? That's only in one trial. What this is, we're doing it over the long run, over buying these types of extended warranties repeatedly on this particular item. The consumer can expect to lose money. So it would be in their best interest just to say, nope, I don't need it, and then to take the chance of the falling in that 5% pool and then just being out the $50. Now, if these numbers had changed, so maybe they offer their warranty for less, maybe the cost of repair is a little bit higher, so then that end up being then where you take those things into consideration on whether or not you should purchase something like this. Okay, but the idea about this insurance is that you're really worried about this one scenario. So the idea is, do you pay up money up front for the case or for the chances that you fall into that scenario? So So as a slightly different insurance scenario, this is going to be for life insurance. An insurance company plans to sell a $250,000 one-year term life insurance policy to a 60-year-old male. Now, of the 2.5 million men having similar risk factors, the company estimates that 7,500 of them will die in that next year. So the question is, what is the premium that the insurance company should charge if it would like to make a profit of $50 on each policy? Okay, so for some of the language, if you're not familiar with how these kind of insurance things work, is the premium is the amount of money that they charge you. Okay, so that's what you basically pay them to take out the policy for the 1 year. Now, at that point in time, if the person does pass away within the year, the insurance company will pay out $250,000 to the beneficiary of the policy. If the person does not die by the end of that year, yay for them, but then they're out of whatever they paid for the premium, right? So the insurance company gets to keep that. That person does not get that back, but hey, they don't have to pay out a beneficiary. So let's take a look at the probabilities for each of the scenarios. So the probability that the person passes away, they found that out of the 2.5 million men, okay, so 2.5 million, it's going to have a lot of zeros in there. All right, so 2,500,000. Having these risk factors, 7,500 of them will die by the end of the year. So that builds my numerator. So in this case, maybe just to get rid of all those zeros, this actually does go down to a decimal very nicely. So that'll be 0.003. So let's maybe just work with this in its decimal form. If it didn't go down to a nice decimal, we would have to work with the fraction, but in this case we were fortunate this decimal isn't too bad. Alright, so that's the probability that they pass away by the end of the year. So the probability that they live will be 1 minus that, or 0.997, right? So there's a really high chance that they will live. And there is this very small chance by the end of the year they will pass away. Now let's take a look at how this affects the insurance company. Now for the insurance company, they will, if the person dies, they will be paying out $250,000. Okay, so since this is a payout to them in terms of their bottom line, we'll consider that to maybe be a negative number because they're going to be out this money. Now, if the person lives, the insurance company doesn't pay out anything and they just get to keep that premium. So then the question that we're going to ultimately answer is, what should that premium be? So that way, over the long run, they make a profit of $50. So based upon these values, let's go ahead and figure out the expected value. So that's the probability that they die multiplied by the money lost to the insurance company. Add to that the probability that the person lives multiplied by the effect to the insurance company, which is going to be 0. Going ahead and putting that in your calculator, you get negative 750. Alright, so what we just found is that the average payout is going to be $750. Now the question is, what should the insurance company charge if they want to make a profit of $50 on each policy? So if the average payout is $750, keep in mind then that the fair price would have been $750. Okay. So the fair price, okay, so the insurance company doesn't make a profit, they don't make a loss. In the long run, everything should balance itself out. The fair price to charge would be $750. That's what they should charge the person for taking out this policy. They don't want it to be fair. They're in the business of making money. They want to make a profit. So to make a profit, of $50, they should charge $50 more on top of this. So they should charge $800.